In this video, I will be explaining a hypothesis test for the proportion. This will be a one-tailed test, and I will be using the z-test statistics approach. The problem says, a company claims that the proportion of dissatisfied customers is less than 0.10. To test this, a random sample of n equal 200 customers is selected and 12 are dissatisfied. Using a 0.05 significance level, conduct the hypothesis test using the z-test statistic approach. So we are going to test if the proportion of dissatisfied customer is less than 0.10. This company is claiming this, so that will be a hypothesis. What hypothesis will be this? Because this hypothesis doesn't have an equal sign, they say it's less than 0.10. This hypothesis that the company is using as a claim, this will be an alternative hypothesis. So I'm going to, in my hypothesis test, I will be typing this as an alternative hypothesis. So this is the alternative hypothesis. The proportion of customers is less than 0.10. And this will be the research hypothesis. So actually that we are going to see if that is true. Obviously the opposite of this will be the null hypothesis. So the null hypothesis will be that the proportion is greater or equal than 0.10. Actually, I'm going to use equal to 0.10. So P equals 0.10. Why? Because I'm going to assume that this is true, that P is equal to 0.10. So in my test statistics, I'm going to use this P as the real value of the proportion. Because I know that this is a test of the proportion, I know that I can use the z-test statistic, the normal distribution. So I'm going to use the normal distribution, and because the alternative hypothesis says less than, because this is a less than alternative hypothesis, there will be only one rejection area, and this rejection region will be to the left. Remember that in the middle of the distribution, this 0 corresponds to the actual mean. And I'm going to consider that the actual mean is P 0.10. The mean in the sampling distribution of the proportion is P, and I'm going to consider that P is 0.10. If I compute the z-score of 0.10, it will be 0. So if I want to check that is less than 0.10, then I'm going to be considering a number whose z-score will be less than 0. For that reason, the rejection area will be to the left. So anytime that we have here a less than, the rejection area will be to the left. And the size of this rejection area will be alpha. So this area here will be 0.05. And I need to compute the z critical value, the critical value that separates this rejection area with the acceptance area. So this will be a z that have a 0.05 to the left, and this will be alpha. So alpha will be 0.05. And to compute this z, I can use a table which value of z have a 0.05 area to the left, but I can use Excel also. So I'm going to use Excel. I'm going to type in whatever cell of Excel equals normal standard inverse of 0.05. Press enter, and that gives me a value of negative 1.6448 that I rounded to 3 decimals at negative 1.645. That will be the critical value. So the value of this z, this critical value, will be negative 1.645. And what I'm going to do is compute the test statistics, and if the z value is in the rejection area, I will be rejecting the null hypothesis and accepting the alternative that the proportion of dissatisfied customers is less than 0.10. Let's see. Let's get the test statistics. So for computing the test statistic, remember the z value will be, this is the formula for the z test statistic for the proportion. It will be the sample proportion minus the population proportion, and this population proportion that I'm going to use is the one that appears in the null hypothesis. I'm going to consider that the null hypothesis is true. And this value p appears several times in the formula. So we have p, because I'm going to use the one in the null hypothesis, and I also have n that were 200 customers. So the value of the sample proportion will be x, the number of successes in the population, so in this case successes in quotation, because in this case will be the number of dissatisfied customers. So there are 12 dissatisfied customers divided by n, that is 200. So we have that 12 divided by 200 is 0.06. So this value of the sample proportion will be the one that we are going to be using here. So we substitute all this value that we have in the formula for z. So this will be 0.06, this p will be 0.10, and n will be 200. So we have this. P equals 0.1, 1 minus p is of course 0.9, n equals 200. So the answer is 0.06 minus 0.1 divided by the square root of 0.1 times 0.9 divided by 200. If I compute this, I get negative 1.886. This value, negative 1.886, is to the left of negative 1.645. So it's very clear that this value will be here in the rejection area. So the z value is in the rejection area, so it's lower than negative 1.645. And for that reason, we reject the null hypothesis and accept the alternative. So it means that there is enough statistical evidence to accept the company claims that the proportion of dissatisfied customers is less than 0.10. So let's type here the conclusion. Because z equal negative 1.886 falls in the rejection area, we reject A0, so we reject the null hypothesis and accept the company claim. So we accept that P is less than 0.10, or the proportion of dissatisfied customer is lower than 10% that the company was claiming. With this, I finish my explanation of how to make a hypothesis test for the proportion in this case. I hope you have found this useful. Thank you.